Let's look at this next problem. We know that the first equation is that of a circle, and the radius is the square root of 10, which is a little bit more than 3. So I'm going to pretend that these units are going by 2's. Let's go by 2's. 1, 2, 3, 4. 1, 2, 3, 4 there. And let's just make those 1. I know this is going to be kind of stretched out, but oh well, I guess we just got to go with it here. So a little bit more than 3 in each direction gives me right about there, there, and there. So here is our circle, which is looking not as circular as it really should. And y equals the square root of x minus 2 tells us take our standard square root graph, move it 2 to the right. So if I go over 2, this graph normally goes over 1, up 1. So I think we're going to have this as our graph, and it's kind of hard to tell, but it might look like 3, 1 is a solution point. Let's check 3, 1 in our two equations. 3 squared plus 1 squared, that's 9 plus 1 equals 10, it works there. 3 minus 2 is 1, square root it, you get 1. Okay, so that is our point, our solution set. Now let's find this another way. Let's use substitution. Let's take this y equals the square root of x minus 2 and substitute it into the line above. That will give us x squared plus the square root of x minus 2. When you square it, that lifts off the radical. That just gives us x minus 2 is equal to 10. Let's now solve this quadratic equation by subtracting the 10 off of each side. X squared plus x minus 12 is equal to 0. That factors into x plus 4 times x minus 3. And we get x equals negative 4 or x equals 3. Now we can see just from inspection that x equals negative 4 is not going to give us a solution, but also if algebraically we go to substitute that into the other equation, it's not in the domain. Negative 4 minus 2 is negative 6. You can't have the square root of negative 6. So that gets crossed off. We take our 3, substitute it in, and find out that y equals 1. And so there is our point 3, 1 found algebraically. Now they want us to solve this system using the addition method, and it seems to me that canceling out those y's is the best move. So I'm going to multiply that first equation by 2 and keep the second equation as it is. The first equation multiplied by 2 gives us 6x squared plus 2y squared equals 42. And the second equation, just sliding it over, gives us 4x squared minus 2y squared equals negative 2. Adding down, those y's are eliminated. We now have 10x squared equals 40, meaning x squared is 4, and x will equal plus or minus 2. So this is our beginning. Now we need to find some y values that match with it. I think when I substitute it back in, I want to go with the first equation because there's a plus in front of my y squared. So here we go. Take this, substitute it right into that top equation. 3x squared. Well, instead of substituting that in, let's just go up the line above where we know what x squared is. 4 plus y squared equals 21. That's 12 plus y squared equals 21. And y squared is equal to 9, and therefore y is equal to plus or minus 3. Now this means when either 2 or negative 2 is substituted in, 3 or negative 3 comes out, and our solution set is 2, 3 and 2, negative 3 and negative 2, 3 and negative 2, negative 3. There are the 4 points in our solution set.